Hello and welcome to today's Saratech Enablement Series. My name is Sarah Utsugi and I'm the Marketing Coordinator at Saratech and I will be your host today. Presenting today we have Peter Ungaro, Siemens DISW Director of Product Management, and he'll be talking to you about what's new in Fibersim 17. All right, hi Peter, thanks for joining us today. How are you doing?
I'm doing great, Sarah. Thank you for having me. I'm thankful to be here today and speak with everyone about Fibersim. Just to introduce myself, I am a Director of Product Management at Siemens DISW, focused on Fibersim and a number of other products in the Siemens portfolio. I'm based in the Waltham, Massachusetts office near Boston, and I've been with the company now for almost 25 years and working on composites and Fibersim for almost 19 of those years. So it's been a long time, and I've been involved in Fibersim for a long time, and I'm hopeful that I can bring some great information to the group today. This is a picture of me in late 2019, which seems like 10 years ago, and this is about 6 months ago, me still socially distancing at an undisclosed location. So I'm safe. I hope everyone else out there is safe, and we'll get into Fibersim. Now, I know some folks on the call might not have a lot of background in Fibersim, so I thought I'd spend a few minutes at the beginning of our presentation to talk a bit about how Fibersim can help in composites design and manufacturing. And primarily, we're attempting to solve problems that composite manufacturers have with increasing the rate at which they can produce high quality parts, being able to be explicit in the design of those components and explicit in the manufacturing of those components, and importantly, be consistent, save material, save time. And separately, expand out into more complex part types, part shapes, part processes, and capture that information within Fibersim and allow Fibersim to help with that overall process. The way Fibersim does that is by defining a digital twin. And you've probably heard Siemens talk a lot about the digital twin and the way it helps companies really focus on what's important in engineering and then downstream to manufacturing and into the rest of the enterprise. And specifically with composites, we're trying to solve that data flow problem. So we're taking the upfront design information, we're standardizing it, we're capturing it correctly, we're being able to make those upfront manufacturability assessments as quickly as possible, assessing cost, production time, and then making that process flow down into the shop floor, basically to have a consistent manufacturing process. And the way that looks when you use Fibersim with the digital twin on the engineering side is on the top left there, you take a surface that you want to construct using composite materials. You basically walk it through the entire engineering process. You can define all the shapes, use different material types, define your drop-offs and your offsets and your through layer thickness characteristics, generate all your shapes, validate the design using cross-sections, design stations. You can then do your manufacturability assessment, which we call producibility. You can then generate all of your outputs for flat patterns and weights and ply tables and drawings, and then you can take it into production. And in production, you take all of that information that you've captured in the master model, and then you can then leverage it on the shop floor using your existing cutting and nesting systems. You can use your existing laser projection systems and leverage those that documentation set to make sure that you're following the correct manufacturing process and sequence. I mean, that's the 2-minute tour of Fibersim at a high level. And what we'll do now is we'll dig in a bit into what we want to talk about, which is how Fibersim has improved over the last series of releases in Fibersim 17. And I have a number of topics I want to cover here. You see them on the screen, then we'll talk a bit about some final enhancements that we've added to the system. So we'll start with forming. This is a new process type that we've added to Fibersim in the 17 series. And the goal with forming is to allow Fibersim to extend to part types that use match mold tooling to actually form components, either from a preform or from a blank that eventually comes into a finished part. And the goal here is to give a designer, again, an upfront tool that has fairly low capability on the physics side, that's the left scale, but fairly rapid solution time on the right, which is the solution time scale. So this is really attracting at design engineers who want to quickly evaluate a number of potential designs that may use forming. Now, you may then have to go up the chain here to an analyst or to real R&D in order to validate the final design and tooling. But the goal here with Fibersim forming is to be able to take a number of concepts, run them through the Fibersim manufacturability assessment, either the geometric assessment or the forming assessment, pare down that set of options that you're trying to look at and trying to understand, and then really dig in on only the 1, 2, or 3 design scenarios that make sense. And in those cases, you may then leverage a more complex CAE tool with a dedicated FEA analyst. You may not. It depends on what your process is. But up front, we're trying to have Fibersim be able to participate in the concept evaluation and concept reduction in this process. We've had some interesting customers adopt this initially here in the last year or so. And we've gotten some good feedback. We've made some modifications across Fibersim 17 to improve this, and we'd be looking to speak with other customers that have interest here in forming. When you actually take forming and then turn it into something, basically Fibersim can simulate that match mold process. And you can see here in these animations, it's actually taking the blank, it's actually pinned, it's a pinned blank that's actually being compressed within the 2 sets of tooling, and it's attempting to identify whether that blank, that compression is actually going to work for that part shape. Okay, so the forming capability allows you to define the tooling, the timescales, and everything that you need in order to do this type of simulation. The next option I want to talk about is about our investments in cross sections. Those of you that have used Fibersim before know that we've, for a long time, had cross-section capability built into Fibersim that allows a designer to take any arbitrary curve on the laminate composite tool and have Fibersim generate a 2D section that shows you the layup. It can label the components. It can really give you insight into how your layup is structured on the laminate. And we have a number of options that you can use to define that cross-section and to render it as some 3D PMI in NX. Now, what we've done recently over the last year or so is heavily invest in a new planar cross-section functionality, which instead of taking an arbitrary curve, it uses a plane to dissect the laminate. And this has some advantages. It allows us to ensure that the resulting PMI is planar, and it allows us to do things like you see here, where we've in the past added shading and some very cool representations of the cross sections right in the CAD system to give you real good visuals that you can use just as 3D PMI that people can view, or you can capture them in 2D drawings, or leverage them in images or doc sets that you create outside the CAD system. So what we've done is a couple of things recently in the 17 series, which is add some additional shaded and centerline capabilities. And you see that here where you can define the centerline of the component, and you can actually have the cross-section build on each side of the centerline. Which is actually really great in visualizing symmetric layups and such, where you want this type of a representation. In addition, we've added additional capabilities where we've extended the draped cross-section type and the scaling types that we use for schematic and draped cross sections. And again, we're just trying to build out the capability that we have in the planar cross section capability. Now it's basically surpassed the prior capability that we had in the system, and most of our customers use this exclusively now in Fibersim 17, and it really does a great job of defining the documentation and the rendering that you need to validate the design. Another thing we've done in the Fibersim 17 releases is we've added a publish to Teamcenter option. So for those of you that are using NX with Teamcenter in a managed environment, we now have the capability to publish the composite object structure, and I'll talk about that in a bit, but the composite object structure into a Teamcenter data model. So starting with Teamcenter 12.3, as you see there, there's now a composite object model built into the foundation capabilities of Teamcenter that can be installed on your Teamcenter server, and Fibersim can publish its composite content, including the plies, the cores, the laminates, including the attributes about those plies, the materials, etc., as a structure to Teamcenter, effectively expanding the composites information out to the enterprise. So instead of having to use Fibersim and potentially view the model or extract the information using one of the many Fibersim export options, you can now publish that structure into Teamcenter and view it there. And you can then leverage that information downstream. If you have a series of parts that are going to be released and you want a purchasing agent to look at the materials being used and the size of the plies, the area of those plies, et cetera, they can start to get a sense of the structure of those plies with those parts without having to have Fibersim or to look at the CAD system. It's all published in Teamcenter objects. And again, this is a really great advance. We've built it into Teamcenter as a dedicated composite object model, and Fibersim publishes directly to it. It's very easy. The user just validates with the Teamcenter server, and the data can be published automatically. Another thing we've done in Fibersim is explicit layer splicing. And those of you who have used Fibersim, again, probably have used our splice tools and our splice groups before. And those are great utilities to splice fairly regular components that are spliced along roll width dimensions in various states. So you can take 0-degree plies, figure out the roll width based on the definition in the Fibersim database. Fibersim will generate parallel curves that you can then apply to a large layer, and it will automatically split that layer up into the individual ply components for you. So it generates the geometry, generates the additional plies, links the geometry so that each ply is unique. It handles overlap, so you can define the overlap distances, etc. There are some cases, though, with extremely complex parts where you might need to have some irregular splicing, maybe not regular curves, maybe not curves that are aligned with the roll width. Maybe you need to work around a particular feature in the composite model. Explicit layer splicing allows you to basically take an arbitrary set of curves and apply them as a splice group to the layers. So you can fully control what the final shapes are by generating the curves yourself and then applying them to the Fibersim composite model. So it's, Fibersim won't generate the geometry for you, but it will let you automatically update all the plies on the layer. You could reuse those curves on subsequent layers. So again, if you have a large part which is fairly thick and you repeat your splicing strategy after X number of layers, let's say 5 or 6 layers, you repeat your splicing strategy, you can reuse that set of curves to do that 5th or 6th layer of splices if you've constructed those curves once. So this is, again, another shortcut. It allows you to deal with more complex geometry and really allows you more explicit control over the splicing capability that's built into Fibersim. Now, all these capabilities that I've talked about here are really focused on expanding the knowledge and capability that's built into Fibersim, right? The ways that users can either define parts using forming or evaluate them using the forming simulation, the way they can document them, using the shaded cross sections and the planar cross sections, and now the way they can divide them for manufacturing using the explicit layer splicing. So we really do attempt to add capability, all across the product suite as we work on the features in Fibersim. Now, those are probably the big headlines, and there was a number of improvements in each area that we were able to put into the system. But we've also done a number of smaller enhancements, and you'll see little changes and little improvements in a lot of different areas of Fibersim with the 17 releases. One of the places that we invested in Fibersim 16 and introduced was our wrapped ply capability. Wrapped plies are ways that you can construct plies in Fibersim that are not single domains on a tool, but actually wrap around themselves. For instance, if you wanted to do, construct a ply that was on a cylinder and it over wrapped itself on that cylinder, we basically added capability that allows you to do that in Fibersim. And we've been slowly improving that capability so that it works more effectively with all of the different areas of Fibersim, including the way we splice, the way we export data to the CAE tools, and all of the different ways we represent the data. And as you can see here, we've made a number of different improvements here where we are able to take those layers and turn them into wrap plies automatically for you. If you construct a layer that ends up being a wrapped ply, we'll recognize that, and then also being able to render wrapped plies in our cross sections. So that was something that was not present until we added that capability in Fibersim 17. And Fibersim also has a very broad set of manufacturing interfaces where we can interface with all of the industry standard tools, be it the various formats that Fibersim uses for exporting 2D flat patterns. You can use the generic DXF or IGES formats. You can also use some formats that are targeted at some of the nesting systems. We also have capability that allows you to export to the various laser projection vendors in all of their various different formats, but we also have automated deposition options within Fibersim that allow you to handle automated tape laying, ATL, as well as automatic fiber placement like AFP. And when the vendors make improvements and approach us and ask us to leverage those improvements and improve the Fibersim interface, we try to do that regularly. And in the Fibersim 17 case, CG Tech, we've been working with them for a long time and have made a number of improvements to their interface to make sure that we're supporting their VCP capability as good as we can, and making sure that the data exchange between Fibersim and their tools is robust and it's seamless to the end user. Another one I called out here is what I call annotation locked. This is the ability in Fibersim to, you may know that Fibersim can generate ply callouts or 3D PMI that might be a ply label, it might be a ply table, it might be something that you want to show on a view in 3D that you could then show to any other user outside of Fibersim. Fibersim can populate that ply callout with data about the ply, the thickness or the material, etc. And we now have the ability for the user to lock those annotations. So if you want to release the model and ensure that those annotations won't update, you can actually lock them, and Fibersim will honor that lock until you unlock those annotations, and then Fibersim can update those annotations as you see fit if you've changed the underlying ply information that supports those annotations. And the last thing I want to call out here is the overall approach we take to Fibersim development and Fibersim releases. We do attempt to listen to our customers as effectively as we can. We do get a lot of input in both enhancement requests, and I'd be lying if I said we didn't get the occasional bug report or issue that our customers run into, and we do attempt to address those as quickly as we can. There's a total of 57 customer reported issues and enhancements that were added to the Fibersim 17 series so far. That number will increase as we add additional releases to the series. And we're constantly listening to those issues that are coming in, prioritizing them, addressing them, attempting to improve the product as best we can to service the customers that are using it every day. Myself, I look forward to engaging with customers when they have questions and want to know how to use our capability as effectively as possible. And our support staff, I hope, is providing good service to our customers. And I would hope that we're responsive. But if we're not, I would encourage you all to reach out to the Saratech team, and they can reach out to me, and I'd be happy to have conversations about how Fibersim can be improved to help our responsiveness in this area. So Sarah, that's it for me.
Great, thank you so much, Peter. At this time, if you have any questions, please go ahead and enter them into the questions panel, and we can get to those now. It does look like a few questions. The first is, can Fibersim use NX value-based licensing or tokens?
Yeah, so this came up about a year or a year and a half ago, where NX started to use more value-based licensing. A lot of customers started adopting value-based licensing to have access to a lot of the different features in the NX portfolio. And we did add the capability within Fibersim 17 for Fibersim to also use those tokens. So if you're a customer and you have Fibersim licenses and you don't necessarily have, for instance, the Fibersim ATL or AFP interface, but you have value-based licensing tokens, you could potentially leverage those tokens to access that capability. And it's documented in our installation guide, and our support team can help you get access to those and how to configure Fibersim to use them. But we have seen customers start adopting that, and it has been quite productive for them to be able to get access to more Fibersim capability.
Nice. The next question is, what versions of NX does Fibersim support?
Oh, that's another good question. For those of you that are new, you might not realize that Fibersim has supported a number of NX versions at the same time. So Fibersim actually isn't just released with each new NX version. When it's released, it supports multiple NX versions. So currently, in 2021, Fibersim is supporting basically every release of NX all the way back to 12.0.2. So quite a few releases, including all of the various continuous releases that have happened since NX 12. And over time, that list will be pared down as more customers adopt the continuous releases. But right now we're supporting everything from NX 12 to NX 1980 series. And we generally release Fibersim support for an NX version within a month after the NX release. So fairly quickly, you can get access to Fibersim capability on the new NX releases.
Awesome. The next question is, where is Fibersim data saved?
Yeah, this is sometimes some people don't realize what's going on when Fibersim is working with NX, but effectively Fibersim is storing the data in the NX part models. So if you're adding Fibersim composite information to an NX.prt file, you're actually embedding the Fibersim data in the .prt, which is great if you're running NX in a managed mode with Teamcenter, because you're automatically vaulting and revisioning the data that Fibersim is creating, within the NX part files. And there's no additional or ancillary files that you need to manage to use Fibersim and have it integrated with NX. So that's quite convenient for our end users.
Great. And the last question we have is, can I customize or automate Fibersim in any way?
Yeah, this is another good one for power users. There are some capabilities to add custom reporting and some ability to export data from Fibersim and automate other processes outside of Fibersim. So for instance, if you wanted to generate a weight and balance report from Fibersim in a particular format that you could leverage in your other engineering tools, maybe it's even code that you have in Excel that you want to run against the Fibersim layup, you can structure that data yourself, generated out of Fibersim automatically through a small script, and you can actually leverage that information in CSV or XML, or use other scripting capability to massage that data and leverage it outside of Fibersim. And that has been used by a lot of our customers for things like reports, and as I mentioned, weight and balance information, and lots of other information that they want to extract from the composite model. So great question.
Great. Well, thank you so much, Peter. It looks like that's all the questions we have for today. But if you have any questions that come up, please feel free to email us at marketing@saratech.com, and we'd be happy to connect with Peter and get those questions answered. If you're ready to take it to the next level, Saratech offers much more than software. We have a wide variety of options for training, services, and 3D printers. So if you have any questions about that, you can email us again at marketing@saratech.com. Thank you so much for attending. Thank you again, Peter, and have a great day.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.